In this video, we're going to look at the trapezium rule and what that does for us and how we use it. Okay, so the trapezium rule is used to find the area under a curve. So in this instance, if I kind of split this like this, and I wanted to find this area under here, that is something that we can't currently do very easily. Okay, we can't find the area under a curve. We can do it with straight lines, but not with a curve. So the trapezium rule is an estimation of the area between the curve and the x-axis. Okay, so what does the trapezium rule look like? Well, what we do is we split this area into chunks like this, equal chunks, equal widths, something like that. Okay, and what we're going to do is each of these turn them into a trapezium. So there, 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 and then we'll do one more just kind of like this. Okay, and if I just sort of move this red out of the way, you can see that they're trapezia there. All right, so the trapezium is a pretty good estimate. You can see like that it's almost exactly like the curve, but it's a little bit out. So that's why it's an estimation. So you need to know the area of the trapezium, which they give you in the exam. The problem with this is it's kind of flipped the other way around. So A and B are the two parallel lines. We don't care which way around they are. And the height is the height of the trapezium, like that. We're using it this way round. And so the two parallel lines, A and B, are the heights. And the height of the trapezium is actually more like the width of this little strip, is what they call it. A bar or a strip. You'll see the word strip in the exam. Okay, so let's say we kind of go 0, 1, 2, 3, 4, and 5. Then the width of each of these trapezia is going to be 1. And that's often the case in the exam. Sometimes it's 0.5, but nearly always it's 1. So the 1 will go into here, the height. It's actually the width. Okay. There is a very complicated formula that you can use to do the trapezium rule. And my advice is to just ignore that and just do each one of these separately and add them together. In the exam, there are 4 strips maximum. Here I've got 1, 2, 3, 4, 5. So let's just go from 1 to 5 and make it a bit more realistic. Okay, this first trapezium then, the area would be a half the 2 heights. So let's just put in some heights here of the trapezium. So let's say it goes up to 30 and this one is like 20. Then A and B would be 20 plus 30 for the heights. And the width of the bar is going to be 1 each time. So I'll put it in to just show, but we don't need to times by 1. So this number 1 strip here would be 20 plus 30 is 50, halved would be 25. Okay, let's move to the next strip along, number 2. We already know that one of the lengths is 20. This one might be 10. So for this strip here, it'd be half 10 plus 20 times by 1. 10 plus 20 is 30, divided by 2 is 15. Okay, and we just keep going along and adding these up and not worrying about this really complicated rule that has this formula that we have to fill in. You can use that if you like, but my advice is just to do it like this. It doesn't take very long once you see the patterns. 5 plus 10 times by 1, 7.5, half of 15. Okay, and once we've done all 4 strips, we just add them, the 25, the 15, the 7.5, and then the final one there, add those together, and that will be my final estimation. Okay, one small part about this topic is whether it's an over or an under estimation. Okay, if the curve is going upwards like this, and I do my trapezium, I've zoomed in on this sort of curve. Hopefully you can see from this that there's this extra little bit from my trapezium which is not needed. Okay, when I do the trapezium area, I'm going to be including this part here, which I don't want. So this would be an overestimate because I'm including an extra part of the area that I didn't need. If the curve goes the other way, like that, and I do my trapezium, then let's try to make that a little bit like that. When I work out the area of my trapezium, I'll be missing some. I'll be missing this area here that I should have included, but I can't because the trapezium is a straight line. So in this case, this would be an underestimate. Okay, so you can look at your curve as whether it sort of curves upwards or it's curving, kind of coming more flat, to see if it's an over or an under. And there's often a link between the trapezium rule and your speed time graph, because if this was speed and time along the bottom, then the area under the graph would be the distance traveled. Okay, so there's a link there. We usually do our speed time graphs with the straight lines kind of going like this, but if it was a curve, we would have to use the trapezium rule to find the total distance traveled.